Martian organics. Evidence suggests life may be hard to rule out. A new NASA-led study indicates that the abundance of complex organic molecules detected in ancient Martian mudstones is difficult to explain without considering biological processes. The findings don't prove life once existed on Mars, but they raise significant questions about the planet's past habitability and the origins of these molecules. The discovery and initial findings in 2025, the Curiosity rover identified long-chain alkanes, a type of organic molecule embedded in the Cumberland mudstone. While not a high concentration at just 30-50 parts per billion, researchers at NASA's Goddard Space Flight Center, led by Alexander Pavlov, now argue that the original concentration was likely far higher, before millions of years of radiation degraded the material. Modeling the degradation, the team modeled the effects of ionizing radiation on organic molecules over the past 80 million years, the approximate exposure time of the mudstone. Their analysis suggests the original concentration of alkanes and/or fatty acids could have been between 120 and 7,700 parts per million ppm, a far greater abundance. This is the core of the study. The original amount is what's hard to explain. Ruling out non-biological sources, researchers then assessed potential non-biological origins for these molecules, including meteorites, interplanetary dust, atmospheric fallout, hydrothermal processes, and serpentinization. However, even when combined, these abiotic sources couldn't account for the estimated original concentrations. The team concludes that the inferred abundance of long-chain alkanes is inconsistent with a few known abiotic sources of organic molecules on ancient Mars. The biological implication on Earth: long-chain fatty acids are primarily produced by living organisms. While non-biological formation is possible, the high concentrations inferred in the Martian mudstone suggest life may have played a role. The study isn't claiming a definitive detection of life, but it does emphasize that alternative, unknown abiotic pathways would need to be discovered to explain the findings. Our approach has led us to estimate that the Cumberland mudstone conservatively contained 120 to 7,700 ppm of long-chain alkanes and/or fatty acids before exposure to ionizing radiation. The researchers write, "We argue that such high concentrations of long-chain alkanes are inconsistent with a few known abiotic sources of organic molecules on ancient Mars." Next steps and uncertainties: the existence of organic molecules on Mars is already well established. The key question now is whether these compounds indicate past habitability or something else entirely. The current study highlights the need for further research to better understand organic formation pathways on Mars, how radiation interacts with organic material in the Martian environment, and whether previously unknown abiotic processes could explain the abundance of alkanes. The study reinforces the idea that Mars once held a more favorable environment for life than it does today. It also demonstrates how complex the search for life beyond Earth will be, as distinguishing between biological and non-biological origins of organic compounds requires rigorous analysis and a willingness to reevaluate assumptions.